Hello, this is question 10 on your Mechanics and Statistics paper 2018 from Edexcel. You have a projectile. Is a boy throws a ball at a target. At the instant when the ball leaves the boy's hand at point A, the ball is 2 meters above the ground and is moving with speed u at an angle theta with the horizontal. In the subsequent motion, the highest point reached by the ball is 3 meters above the ground, and the target is modeled as being the point T, shown in figure 4. Ball is modeled as a particle moving freely under gravity, and we have to prove that u squared is this expression here. So one of the things that we can easily use is that we know the maximum height. So from the starting point, the maximum height is going to be 3 minus 2. So it's going to, the maximum height reached by the particle is going to be 1 meter. 1 meter from the height that is projected. And we know that maximum height means velocity 0. So we can apply Subat equations. If we write Subat, and I'm going to consider positive up. Maximum height is going to be 1 meter. Initial velocity is u. The vertical one is u sine. So my components are the horizontal one is u cos because it's adjacent to alpha, and the vertical one is u sine alpha. So in this case, I'm talking about the vertical one, so u sine alpha. We don't need the final velocity. Acceleration is minus the gravity, minus because I consider positive up and gravity goes always down, and time is going to be, sorry, I know the final velocity. This velocity at the top is 0. The time is what I don't need. So I'm going to use a Subat equation without t, which is this one. So v squared is u squared plus 2as, and I'm going to substitute what I know. V squared is 0, u squared, sine squared, so I'm squaring the velocity, minus because the acceleration is negative, and I'm going to leave just g because they leave g in the expression, minus 2 gs, which is 1, So this displacement is 1, and I just make u squared the subject, so u squared is going to be 2g divided by sine squared alpha. That's precisely what I have to prove. So that's part A. Then the point T is a horizontal distance of 20 meters from A and 0.75 meters above the ground. So this point T, this horizontal distance is 20 meters, and the vertical height is 0.75 meters. Find the side. The ball reaches T without hitting the ground, so find the size of angle alpha. So we can consider in this case, as we have we have the horizontal distance and the vertical distance, we are going to work with both motions, the horizontal and the vertical one. So remember, the horizontal one, when I have projectiles, is constant velocity motion, because my I don't have any horizontal forces acting, so this velocity, horizontal velocity, is constant all the way. So if I consider that, I'm going to do it here. So for B, if I consider the horizontal motion, I have a just horizontal constant velocity motion. So velocity is distance divided by time. So my horizontal velocity, we say, is u cos alpha, is going to be the horizontal distance that we know is 20 divided by the time that we don't know what it is. But then we have a connection between u cos of the angle and time. If we think about the vertical motion now, vertical motion is freely under gravity. If I consider this positive, from here to here, my displacement is, this is 2 meters and this is 0.75. So this distance here, from where the particle goes to when it finishes moving or hits the target, is 2 minus 0.75, so 1.25. So this is 1.25 from this height. So my displacement is going to be minus 1.25 meters. Initial velocity is the vertical one, so u sine alpha. Final velocity, we don't need it. Acceleration is minus g, again because I consider positive up and gravity is down. And the time is going to be the same that this time here. And that's what I'm going to use. I'm going to write a Subat equation without v. We know that can be S is ut plus 1/2 at squared. I substitute what I know. So I have u sine alpha t minus g divided by 2 t squared. Yeah. And now I have this equation, and I need to find an expression. No, I need to find the angle alpha. So what I'm going to do is eliminate t between these two and see what happens. So if I eliminate t, I can make t the subject here in the first one. So t is going to be 20 divided by u cos alpha. And you will see that we're going to have tan alpha very easily. So if I substitute in the second one, I have minus 125 is u sine alpha. And instead of t, I'm going to write that expression that I just found. So u cos alpha minus g divided by 2, 20 u cos alpha squared. This u with this u are gone, and sine divided by cos is tan. So I have minus 1.25, 20 tan alpha. And you'll see that we are going to get the tan as well here. So we have minus g divided by 2. This one square is 400. 400 divided by 2 is 200. So I can write minus 200g at the top. And in the denominator, I have u squared cos squared. U squared cos squared alpha. But I know what u squared is. I have an expression for u squared, which is this one. So I'm going to use it. Even if you're not able to deduce it, you can use it. So 2g divided by sine squared. So this bit here, and I think I'm going to, I don't know, I'm going to copy the whole thing again. So 125 is 20 tan minus 200g. And instead of u squared, I say I have 2g divided by sine squared. Sine squared theta times cos squared theta alpha. And then I can cancel g. I have 200 divided by 2 is 100. And I have the reciprocal, so 1 here, and cos squared divided by sine squared. Yeah, the reciprocal of cos squared divided by sine squared, which is tan squared, cot squared. So the reciprocal is tan squared. Yeah, I don't know. Maybe you can just, so this bit is cot squared because it's cot squared alpha is cos squared divided by sine squared, and I have 1 divided by that, which is tan squared. So the whole thing is going to be minus 1.25 is 20 tan. We cancel the g, and then 200 divided by 2 is 100. So minus 100, and tan squared alpha is a quadratic, so I have 100 tan alpha, tan squared alpha, minus 20 tan alpha, minus 1.25 equals 0. When you solve this quadratic, you get tan alpha is 1/4, or tan alpha is minus 1/20. But I know alpha, there says alpha is above the horizontal, so it's in the first quadrant. If it's in the first quadrant, tan is positive. Yeah, so I can ignore this second answer. Tan alpha is 1/4, and when you do tan minus 1, so alpha is going to be tan minus 1/4, which is 14.036 degrees. We can round 3 significant figures, so 14 degrees, or 2 significant figures. And that's your answer. Yeah, that's the angle. And the next thing they say, so the next is state one limitation of the model that could affect your answer to part B. So we haven't considered a resistance, and they don't mention that, or wind effect, or something like all that. Usually these answers are quite similar. So wind effect, for example, wind effect, consider the wind effect. And the last thing, so find the time taken for the ball to travel from A to T. So we need time taken from here to here. We have an expression for the time. So we have this expression here, where we know that T is 20 divided by U cos alpha. We know alpha. So if we know alpha, we know cos alpha. We would need to find U. But again, we have an expression for U. It's this one here, in terms of alpha. So we are going to use this expression to find U and then go to that one. So alpha, so I'm going to find U first. I know that U squared is, we say 2G divided by sine squared alpha. So if we substitute what we know, so I would keep this in the calculator, even in the memory. So use all the decimals. Don't use the rounded value, round at the end. So keep this value in the calculator. Do sine of that angle, square it, and then divide 2G by that value. If you do that, you have this value here. And when you square root it, you do U is 7 root of 170 divided by 5. That's U, which means the time is going to be 20, just coming back to this expression that we have here, 20 divided by U cos alpha. So 20 divided by U, which is 7 root 170 divided by 5, and cos 14.0, all that with the calculator, yeah? So keep the number, and this time is 1.129 seconds. We round again, I would say to the same, just to be consistent, so 1.1 seconds to two significant figures. And that's all with this question. That's the last thing they ask. Yeah, that's all.